Hi, everyone, and good morning, good afternoon, good evening, wherever you're joining us from. And welcome to our ARM Tech Talk today from Eurotech. I'm really excited to have them at our ARM Tech Talk today. This is the place, if you're joining our ARM Tech Talk for the first time, excuse me, got something in my throat. If you're joining our ARM Tech Talk for the first time, this is the place for the latest in trends, technologies, and best practices from ARM and our ecosystem partners. And we've got one of them today, as I mentioned, Eurotech. So we're going to get to the talk today in just a moment. But before we do, I've got a couple of little housekeeping items I want to go through. So Marco, would you be able to flick to the next slide just so I can tell people how they can get involved in today's conversation? They can not only tweet us using the hashtag ARMTechTalks, they can also view you can view all the Tech Talks on demand at youtube.com/ARM. There's close to 60 of these now, which is just awesome, covering everything from AI to IoT, Matter to ARM virtual hardware. Everything on there is fantastic, great content from ARM and our ecosystem. So do check that out. And if you like what you see today and you want to sign up for another of our Tech Talks, just head to arm.com/Tech Talks to do so and just hit register on upcoming ones. We've got a couple lined up and we've got some big events coming up. So let's have a look at what's coming up on the next slide. We've, of course, today going to hear from Eurotech about how you could reduce friction at the edge and bootstrap your IoT projects. And actually, we're going to hear a bit about Embedded World, which is coming up on March the 14th. For Eurotech are going to be there. And we're going to talk a bit about that today and how they're working with ARM at Embedded World as well. Next week, we've got Keekso talking about how you can use ARM virtual hardware and their tools in a really exciting demo around noise detection. As I mentioned, we've got Embedded World on the 14th. We've got TinyMail Summit on the 28th, and sandwiched between them, we're going to hear from Remotic talking about how you can use ARM virtual hardware with their tools and their service. So do keep an eye out for all of these talks. They're on arm.com/Tech Talks. You can register now. Please make sure you do, because sign up and registration amounts and quotas are limited. So make sure you secure your place early. We don't want you to miss out. Let's talk about today's talk, though, right? Before I hand over to Marco and Luca, who are going to introduce themselves in just a second, I just want to remind folks that if you've got any questions at any time during today's talk, to use the Zoom Q&A box button down at the bottom. It should be in your menu bar. So just ask the questions there for our panelists. That's enough from me. I'm now going to hand over to Marco and Luca, who are going to introduce themselves and tell us about today's talk, which has got a really exciting bit of content and a great demo. So Marco, I'm going to hand over to you first and introduce yourself. Thanks so much for joining. It's great to have you.
Thank you, Tobias. It's really a pleasure to be here today. It's a great opportunity. We're very excited to be part of this ARM Tech Talk. My name is Marco Carrera. I'm CTO of Eurotech. Today here with me, I have a colleague of mine, a dear friend, Luca. You want to introduce yourself?
Hello, everybody. It's a pleasure to be here, and thanks for joining this Tech Talk. I'm Luca Dazzi, and a Principal Solution Architect here in Eurotech.
Excellent. Thank you, Luca. As I said, really excited to be here, welcoming your questions. Feel free, use what Tobias suggested as channel to communicate with us. We really want to keep this as engaging as possible. Yeah. We prepared a small agenda of what we will be covering today. We will start with a quick introduction about who is Eurotech, where is it playing, where is it from, and what we are doing. We are going to be presenting some of the use cases and some of the recent IoT projects that we have worked on in Eurotech, real-world customer scenarios. We'll use these use cases to highlight the challenges of IoT adoptions and what we have worked on with ARM to address those challenges, to reduce the friction of taking IoT projects into real-world deployment. We're going to be closing up with a live exciting demo. Luca will be handling that part to show you how some of these technologies come together to address these challenges and reduce the frictions. So with that topics, let's get started, right? So let's introduce Eurotech. So let's see if we're moving to the next slide. Too many. Here we go. So introduction of Eurotech. So we're an Italian company. We're based in Italy. The headquarters is close to Venice in the northeast of Italy, but we have a global footprint, right? Around 400 people, heavily focused on R&D. We have offices in North America, so in the US, in the UK, and in Japan. In fact, 80%, 90% actually of our revenue is outside of Italy, right? Distributed between the three continents, so US, EU, and Japan. We serve a global 2,000 customers. That's how we learn about what are the real challenges in the world and what we can provide as technology to address those challenges. We have a long history. We dated back to 1992. We started as an embedded company, especially in the embedded space. So we take enterprise class technologies and adapt them into industrial IoT and embedded cases. But also proud to say that we have give small contributions to the history of IoT. In 1999, we were co-authors of the MQTT specs with IBM. We later donated that IP to the Oasis Foundation in order to make MQTT an open standard and laid one of the foundations for the communication protocols into IoT use cases. In 2012, we were also founding member of the CLIPS IoT Working Group. It is one of the most recognized open source foundation initiatives regarding IoT. Within that initiative, we incubated 2 projects. One is called Eclipse Cura, which is an IoT Edge framework, ESF. Everywhere Software Framework is the commercial counterpart. Then we also have an edge management platform whose open source project is Eclipse Kapkua, and Everywhere Cloud is, again, the commercially supported counterpart offered by Eurotech. We'll see both of these software in actions to actually see the value that they bring both at the edge and in the cloud. Our history of complementing hardware with software actually reached an important milestone in 2021, where we certified what we think is one of the first IoT edge gateway based on the state-of-the-art cybersecurity standard, the IEC 62443, in particular the -4-2, so the component level cybersecurity standard. This was achieved through tight integration of hardware and software, and actually leverages some of the ARM technologies that we will be introducing into this talk. As a direction and where we are going forward as Eurotech, we are expanding everything that we have learned about embedded and gateway technology into industrial PC, edge servers, and especially edge AI, introducing in last year and this year more edge AI appliances. This is also a good introduction about where do we play. So if we actually take an IoT stack that goes from sensors to full-fledged applications, we actually sit in the middle. It may be the boring data plumbing that some people refer to, but it's an essential and necessary component to actually instrument an IoT application. Is actually one of the places where a lot of IoT effort may actually get stuck, because you have to break down the silos of the OT domain where some of these sensors live and bridge that with the IT domain where the data extracted from these sensors have to be made available to your business analytic, your business intelligence to actually extract the business value. In that middle layer, what we offer is a hardware portfolio of edge gateway, edge servers, and edge AI, certified for the different industry and ready for global deployment across the different geographies, complemented by software components that simplifies the southbound connectivity of the data instructions and the northbound connectivity bridging into that IT space that we talked earlier. To see that in actions, I actually want to highlight maybe 3 use cases where we have implemented these technologies. The first one that we're actually very proud of is Deutsche Bahn. So Deutsche Bahn is one of the largest train operators in Europe. So based in Germany, but it actually has a large fleet of locomotors for their commercial operations. So 2,000 plus locomotors moving cargo trains across actually most of Europe. They came with a challenge of retrofitting those locomotors with intelligent components that allow them to give them a more real-time visibility of where the fleet was, how it was operating, in order to extract operational efficiencies that they now have. So moving from standard periodical maintenance windows to predictive maintenance, having the ability to do more performance management on where these locomotives were used and the outbound and the inbound paths that these locomotives had to use, giving flexibility to their operational teams to access a large data lake out of which they could extract metrics for better operational efficiency. This had to be done in compliance, of course, with safety. So we had to install gateways that could not interfere or tamper with the safety mechanism. With the real-time aspect, so each of these locomotives is actually exposing more than 5,000 data points with refresh rates that goes up to 16 milliseconds. So there is actually a pretty important performance requirement into that, and especially with large flexibility. Initially, they wanted to create a data lake, but they also wanted to explore what is the value that they could extract of that data lake over time. So they wanted to have the ability to evolve the application, start with a minimal viable product, as we often hear into IoT projects, and then evolve the business extraction of the value as they go over time. Last but not least, security and lock-in were a key component, right? So they had to be a secure solution, and it had to be a solution that could evolve and last over time. So it could not be tied to a single vendor. So in this case, our value proposition of an open source foundations and a certified cybersecurity were a key into producing that. So we are now into deployment of this. So all the locomotors are being installed, and if you are seeing a Deutsche Bahn cargo train, you will know that a piece of Eurotech technology is running in there and collecting real-time metrics as they move around. The second use case is actually in a completely different domain, but it also shows us how a lot of these technologies can be horizontal, right? Some of the challenges are actually quite common. Is on the medical and healthcare. The customer in this case is Fresenius Medical Care. The need was actually to enable remote data collections of water purifier used in dialysis treatment. Fresenius has over 4,000 clinics where these machines are deployed, and because of the medical regulations, these machines did not have embedded connectivity. So it did require regular visits by their operators to actually go and extract operational metrics out of these machines in order to create the data that they could use to see if there were any malfunctioning or any efficiencies that were not yet exploited in the operational aspect of that. In addition, the nurses of each of the clinics by protocol had to visit each of these machines multiple times a day, actually checking if the machine was operating within the right operational window of that machine, and that required visits either to the basement or the machine room and so on and so forth. So by adding additional and retrofitting gateways into these machines, they were actually able to automate the data extraction, enable even some edge analytics, report status both to the local nurses, as well as creating those data lakes back into the OEM, the Fresenius Medical Care Center, to actually operate a full data analytics through the full fleet of devices being deployed. The last use case is on smart electrification. So in this case, ABB actually wanted to put together a reference project into a smart building of their headquarters, where they wanted to consolidate the different energy sources coming from the solar panels, the renewable energy, the chargers that they had for the electric vehicle, calculate a full CO2 emissions footprint and the savings they could have by changing some of the operational policies. Again, it was for a universal gateway, so a very flexible gateway that was rich in I/O, small and compact to actually be fitted into their circuit breakers cabinets. And here HARM came to the advantage because of the low footprint and the low power requirements that the ARM technology brings. So the gateway that was used was an ARM-based gateway with our software framework, gathering all the data at the edge, sending that data. In this case, the cloud partner was AWS. We're using some of the advanced analytic and the forecasting capabilities that AWS had in the cloud. Was able to give them that operational dashboard that would give them a much better insight into the footprint of the building and how they could optimize the different energy sources to reduce their carbon footprint for the whole company. The use cases were very different, but you can probably extract already a theme that the challenges that each of these customers had in adopting IoT projects was actually quite similar. In fact, there are many industrial reports out there where you can actually extract that there are some critical challenges when people adopt IoT projects and how they actually scale them. One is certainly cybersecurity. There is a high risk around it. That risk may not make it worth it. There is a lack of knowledge and a framework on how to approach it. The other one is interoperability and fragmentations, right? Every data source is different. We talked about the different silos that you need to break. So there is a high barrier of entry when you approach these projects. In fact, there are many reports out there that the mortality rate for IoT project is really high, right? There are statistics that are actually reporting 75% of the IoT projects do not make it beyond the POC phase, right? So people are not able how to scale it beyond the initial experimentations. What can we do about these challenges? So we have been working with ARM in the past couple of years. We have been one of the adopters of their Project Cassini, a collection of standard security and ecosystem initiatives to reduce some of these challenges and to remove some of this friction that is actually preventing companies to adopt IoT at a larger scale, reducing their time to market, minimizing the risk, and giving them a foundation on top of which they can evolve their offering. So what we can offer as Eurotech at this point is a hardware and software solution that revolves around three pillars, right? We want to make it simpler to acquire the data at the edge. We come with a bundle set of Fieldbus protocol that are ready to use. We want to make it simple once that data is acquired to process it at the edge and send it into the cloud through certified northbound connectors. Through the collaboration with ARM and through the PSA certified initiative, and by adopting a security by design principle as defined by the 62443 cybersecurity norm, we also to offer our customer a pre-certified solution that comes with a security peace of mind. We're doing that also at the software level by enabling and adopting latest security framework like ARM Parsec and simplifying the management of these devices over the whole life cycle, starting from a zero-touch provisioning. We'll also stay rooted to our principle and offer a solution that is based on open source technology, therefore reducing your lock-in and give you the highest flexibility on how you adopt this technology across the life cycle of these solutions. With this principle in mind, we currently have a portfolio where we adopted ARM technologies both in industrial use case in our ReliaGate 1014 and for transportation and the fleet use case through the DynaGate 1014. These are quad-core 64-bit ARM CPUs. In these packages, as we said, we certify them from the different industry verticals and for global cellular deployments across the globe. And we make sure that they are ready to use packages, right? Reducing as much as possible the amount of effort that you, as a company that is endorsing a new IoT project and starting one of these journeys, reducing the amount of effort that you have to do to actually get that into productions, right? So we do that through the security certification, the flexibility of ARM system ready, and the pre-qualifications. The hardware piece is complemented with an IoT Edge framework, ESF. We mentioned that a couple of times. It comes with the Fieldbus protocols and a low-code environment that you can use to model your data sources, enable edge processing through them, and connecting them directly into the cloud. Luca will give you a full end-to-end demo of this, showing how to get data out of a Modbus, for example, data source, and bringing that all the way up to AWS IoT Core. This functionality layers over a secure foundations that is securing data at rest, securing data at transit, and ensuring the management of all the pieces into that device through the life cycle of the device, from the manufacturing to the commissioning to the provisioning and the maintenance of the device in its life cycle. I will not go over them, but we want to see it's a rich set of Fieldbus protocol that we offer for the southbound connectivity. We will show a couple of them into the industrial sector, but the same devices can actually be used to interface to PLCs that are based on Siemens S7 or Allen Bradley, to energy devices. So if you are running on an RTU and a base stations, to a transportation if you are deploying your devices on a vehicle. And with that introduction, I'm very pleased to hand it over to Luca, who will show you some of this technology in action.
Yeah, so thanks, Marco. Let me take the screen here. And yeah, so I think we can start just giving a little bit of an introduction overview on the demo setup, right? So you already shown something like that, but basically what we have done in order to show you guys how we solve these things, all the use cases that Marco was presenting are basically involving this process, right? We have something to which we have to connect to gather data from. We have to process somehow this data on the edge, and we want to send this data out to our cloud provider of reference, right? So in the demo, we have a ReliaGate 1014, which is one of the platforms Marco was talking about. On this platform, we are running ESF, and we will use a driver to collect data from a Modbus simulator in this case, right? It's just a matter of understanding how collecting data from a field device works. We will do some basic edge processing and send data to our edge management application, which is Azure Cloud, to AWS MP Core, and also to Azure IoT App. So on top of this gateway, we have ESF installed, and ESF exposes a web interface, right? So the first thing that I want to do, I want to log in to my gateway. As you were seeing, we have several authentication methods. So just everything I'm telling you here is based on a secure system. So Aerotech is completely, taking care of all the complexity of security or integration with the hardware and so on and so forth. So what you're left with is how can I gather data from the system, right? So in my PC now, I'm just running a Modbus simulator here, which you might know if you play with Modbus, if you have played with Modbus before, right? So we have just a list of variables exposed as holding registers here. So what I can do on ESF, I have a section dedicated to drivers, right? So I can create a new driver, right? In this case, the list of drivers depends on the drivers I've installed on the system, but as Marco was telling you, we have an extensive list of drivers depending on the protocol you're interested in. So in case of Modbus, I created a Modbus driver, and of course I have to point it to the hardware, right? So in this case, of course, it's pointing to my PC from the gateway, right? Which my PC is running the Modbus simulator here on port 502. Once I have access to the device itself, to the sensor itself, I can create assets on top of that, where assets are just a list of data points that I want to read from the driver or write to the driver, right? It's a bidirectional paradigm that we have. We can read and write according to the needs of the use case, right? So in this case, I have these 4 channels. And as you can see, these channels, I've given names to these channels, even if Modbus doesn't have the concept of naming a variable, right? So these channels are just pointing to a specific slave in the Modbus, to holding registers, to specific memory addresses, right? And we have several data types that we can play with on Modbus. Modbus is kind of a non-standard standard, right? There are many quirks in it. But basically what we can do here, you can see we can create this table. Of course, this table can also be uploaded via CSV file, right? So you can have your map, the map of the registers given to you by producer of the manufacturer of the sensor, right? When I'm reading this data, what happens is that basically ESF is abstracting all the complexity, right? So here ESF, disconnected from the device. So as usual, right? Should be connected. So what ESF is doing in the background, ESF is abstracting all the complexity of reading and writing data from and to the asset, right? So what we end up with is just a list of variables with name, type, and value, right? So just to give you as more example, if I take my simulator here, I can put a stay on top. So we have this temperature here, right? Which I can put, I can change this to 13 example. And if I refresh now, you will see that this has changed, right? So I also have some automation with this driver, which we will use later. So and this basically is how we abstract access, right? So whatever protocol you're using, when you read data from ESF, you will always see a list of variables with type and a value, which is what you're interested in, right? Then there is the second part. So now we can gather data from any protocol we want, from any device we want to field. We want to do some kind of edge processing of this data, right? So for that, we have a no-code, low-code environment, which we call ESD Wiregraph, right? Which is basically a canvas, as you can see, in which you can add components, right? And we have an extensive list of these components. These are just some of them, but this list is completely pluggable. There are components in the Eclipse marketplace that you can download. There are components on our website. you can create your own custom components with the SDKs. These are Java components, right? So once you have your components, you can create your flow, right? So in this case, what we are doing here, we have a timer component, which every 2 seconds is just sending a ping to this asset, which is the one we created before. So every 2 seconds, I'm performing this operation. So I'm reading data for these values, right? And the wire graph is then sending this data forward. Then we have a script, right? So we have this is just a JavaScript filter. So I can add JavaScript logic, right? This to this stream of data. And then I'm just publishing this data to 3 cloud platforms. So just to give you an idea of how this works, just let me connect to a logger, right? So this one is the device logger, right? So I'm logging into the logs of ESF itself. And if I access the log file, second, I can type password correctly. 3rd time charm. Okay, you will see that now. This is every 2 seconds. It's reading data from the bus and publishing data to the logs, right? So and once again, if I change here the value, 31, you will see next read will be 31, right? As you can see, right? So I can now process this data on the edge, right? So I'm applying this kind of filters. What I could do, right? I can also send this data to a database. So I have a local database connection here on this app. So I have a metrics database which is running inside the gateway, and I'm just pushing this data into a database table, right? This database table is called, as you can see by the configuration, metrics table, right? So I can also do local storage. Incidentally, we have local SQL console here. You can see that on this table we have the data that we are reading from models, right? Something like order by timestamp to have them in order. You can see once again, if I change here value, it's 32. I wait for a couple of reads and I run. You can see that I'm pushing this data inside the database, and this database is managed automatically by ESF. Don't have to create the table, right? Everything is managed automatically. And of course, once you have a database, the next thing that I can do, I can apply an SQL on the database, right? So I have this SQL example, which, for the smart guys there who will understand, this one is just an average on an average of the temperature on the past 20 samples, which is called AWG temp, right? So what I can do, I can have another flow, right? So let's say another timer, which every 2 seconds is alerting this filter, which then will send data once again to the logger, right? So let's disconnect this one. And if I do this now, you will see now that that this is publishing our average just one time. So sorry, just should have done the other thing around. So I'm just sending data to the database, and then I'm applying a filter to it. You will see that now we don't have any data, but as soon as we change the temperature, right? So let's say we put temperature to 50, right? You will see that this will start publishing a moving average of the temperature, which is raising, right, every 2 seconds, because we're doing the average of the past 20 samples, right? And we're doing that, as you could see, just writing a simple SQL query, right? And then we have the last part, which is once I've done all these. And by the way, this is just basic, edge processing. We can also do inference on the edge, right? We can have a Triton server running inside the gateway and use a Triton component here on the wire graph to alert a specific edge model, edge inference model, to do processing for us and use the result of that model in the wire graph, right? So you can imagine any kind of edge processing here, really. Once I have my models, right, I want to send this data not only to the log, right? That's just for demo, right? Let's say I want to do something more useful with that, right? So what I did here on ESF, I also created a couple of cloud connections. So the good thing about this project is that this framework is that it's completely based on open source and it's completely agnostic from the field and the cloud, right? So we have created a AWS cloud connection. So let me go on the status page. It's easier to see. So we have an AWS cloud connection, right? A cloud endpoint, which is using a specific client ID, so Legate 1014 ARM Tech Talk. And you can see we have this thing here on AWS console. We also have an Azure TPM cloud endpoint, right? Can you hear me? Oh, yeah, sorry. We also have an Azure TPM cloud endpoint, which is connected to a specific Azure thing, right? And we also have one of our, everywhere cloud connections. We have a thing connected to our Edge management platform, which is this one, as you can see, Legate 1014 ATT, right? So on each one of these, I can have publishers. So I can publish data to a specific shadow in AWS, to a specific twin in Azure, and to the database of Everywhere Cloud. And to do that, I just need to do basically nothing, right? It's already doing that when data changes, right? So let me start some kind of automation. So let's say I want to start some automation. So this will generate data which changes every 2 seconds. So I have something to send to the cloud, right? And let's start with Everywhere Cloud, right? So let's see here, if I go on the cloud connections, you will see that I have an EC Cloud publisher, which is publishing to a specific application ID and to a specific topic. So if I go on Cloud, on the database, you will see that now I have the ATT application, I have my Modbus sensors, and I have, as you can see, my values here, which I'm reading. You can see that I'm staying here in real time, right? From that's Modbus simulator. Same thing can be done on AWS, right? So I can have my shadow here, and you will see that the shadow in AWS contains exactly those values, right? That are changing in real time every 2 seconds, right? And exact same thing I can do on Azure, right? I have my thing on Azure. I have my Azure is a little bit slow. We have to give it time to react. Okay, so we have the twin, and you can see that on the twin I have my data here. So fresh manual, which is
so Luca, just to make sure I understand. So you get all this without having to set up anything, right? There was no setup required on AWS Azure on making sure that the model of your sources get published into the cloud, right?
Nothing at all. Of course. So the point is that one is exactly that one. I model the data just on my drivers and assets. And with the model that I create here, I can, of course, enhance and enrich this model on the Wiregraph. But once I created my model on Wiregraph, I have everything ready to use that data to the cloud. Yes, that's really great. And of course, then I can use Azure AWS services to route this data to a database, to other services. I can use the Azure services to gather data to BIs and so on and so forth. So.
And this is also bi-directional, right? You could use AWS APIs and Azure APIs to actually actuate something back into devices that are connected to the gateway,
exactly.
Right?
And we don't limit that to twins. So we have the twins are, of course, bi-directional by definition, right? But then other than the twins, we also have implemented direct method invocation, message to devices on Azure. We have implemented thing messaging on AWS. So, and this one is everything you see here is completely abstracted by the cloud of reference. Of course, we have same thing on Everywhere Cloud, right? So just to give you an idea, if I go on the assets here in the cloud, I have also here in real time the value that I'm reading from that Modbus simulator. And as you can see, we have just name, type, and value. Once again, nothing else to do, right? So even complex scenarios can be solved in a matter of minutes, right?
Excellent.
Yeah, so I think that shows what we want to show, right? We could go over to device management, we could go over to security in depth, right? But that will take a while. So let's wrap it up just for data manager right now.
That's a good point, actually, because we certainly hope that there will be some of our attendees today, either online or offline, that are eager to learn more. So That's a good segue to actually say that Eurotech will be presented at the Embedded World, right? So we actually have two speeches. They are co-hosted with ARM. One will actually be on the usage of and on the continuous integration and continuous deployment integration on embedded devices. So how we, as Eurotech, use and leverage ARM virtual hardware. And the other one will actually be on the scalability of the security. So how to enable zero-touch provisioning at scale, right? Which is one of the big challenges of deploying a real-world IoT project. So we certainly welcome, if you're at Embedded World, engage with us, come with our speeches. We actually have very interesting demos that may expand on what Luca showed you today, and we can go deeper on what was showed, put that in different contexts, and also expand it on the device management. We will have an interesting robotics demo in our booth, but we are also guests at the ARM booth with the ABB demo that I presented earlier into the use case, and in the AWS booth with an energy demo. With that, Tobias, thank you again for having us today. We hope that was interesting.
That was awesome. What a great talk. You know, when you look at ARM Tech Talks that we've done in the past, the best ones are always ones that feature a demo, and what a great demo this was. So, you know, such passion that came across from both of you, and a really, really important topic that we've covered today. So I really appreciate it. And as you mentioned, right, you've already kind of done my work for me when it says come and visit ARM and Embedded World, right? You guys have got a great presence at Embedded World. Of course, I'm going to highlight the fact that you're on ARM booth, Hall 4, Stand 4, 504. You can find out more about their talks. You can find out more about the demo and the booth and all of the talks and all of the demos at the ARM booth by visiting arm.com/embeddedworld. So please do that. We'd love to see you there. I'll be there personally. Which are either of you guys going to Embedded World, Marco, Luca?
I'll be there, so it will be great to connect there. So certainly want to get a coffee together. Yes, absolutely.
Exactly. And Luca, will you be there yourself?
I'm not sure yet. I'll do my best to be there.
No worries. Well, it'd be great to meet you folks there and meet anyone else there. So I'm really excited.
Absolutely.
For that. So as ever, I've got probably got about 5-10 minutes or so for left. So folks on the call, if you've got any questions, please use the Zoom Q&A box to do so. We'd love to hear your questions. This is the bit I always love. So please do ask away. I've got a couple of questions that I'd love to ask our panelists. So, you know, we've talked a lot, a really great topic today. And one of the things I wanted to kind of ask you guys to go a bit more into more detail on is around PSA certified and these kind of cybersecurity certifications. Can you talk about how important, how relevant they are to your customers?
Absolutely. Thank you. Great talk, right? And great questions. So we talked about how there are some key challenges when technology and companies are actually trying to embark into a new IoT project, and how cybersecurity in all this list is coming up at the top, right? Is the biggest concern, is the biggest roadblock for new companies that want to start into this journey. And there is no silver bullet, right? Cybersecurity is a very complicated project. Some of these companies come from a more operational technology background. They are not at the level of understanding the IT challenges of cybersecurity, so they get scared away. So that's why reference framework like the initiative that ARM has put together with PSA are so important, right? They are really a paramount importance into making sure that they provide a blueprint the company can follow, right? So a blueprint that allows them to have a roadmap, a path to follow to embed security by design in their product from the conception, both for brownfield as well as greenfield projects. So PSA gives you the peace of mind that you have adopted the based guidelines starting from the root of trust, right? The boot process that ARM is so committed to, as well as the evolution and the extension of the change from the boot to the Linux kernel, the root file system, the management, and so on and so forth. It gives you that blueprint that shows you that there is a path to getting a secure system, right? So it decomposes a challenge that is that looks so insurmountable initially to something that you can act upon. You can get partners, you can have proven technologies, you can compose your solution around it. So we were really enthusiastic in joining PSA, certifying our product with PSA. We make that part of all the new devices that we work upon. We actually expanded on that also to endorsing also IEC 62443 in some of these devices. But PSA was a great initiative, and we actually see customer resonating to that, right? They actually see the value of having a reference framework that you have certified against.
That's awesome. You know, PSA certified is so important, as you said. So it's great that to hear that from yourselves and your customers as well. And actually, you did mention something during that last answer that I wanted to touch on as well. You mentioned about greenfield and brownfield deployment scenarios. Can you talk a bit more about the differences between those for these IoT applications?
Absolutely. Luca, maybe you want to take that?
Yeah, sure. Yeah, that's an interesting point. So the most of the times, you know, you have an equal distribution of greenfield and brownfield, you know, scenarios on the pre-phase, right? So the important thing there to manage both of them is to be completely agnostic. As you were seeing, we have you know, we try to implement all the protocols used you know, in the maxes that we play in, right? We have to be agnostic also on the cloud side, right? And also, you know, we are based on open source, and we try to be as close as possible to continue using just open standards in whenever we want, right? And actually, the ARM system ready certification is quite important for that also, right? Because, you know, it gives a certified platform for you know, in which you can run whatever application you want, right? Most of the times you start with a brownfield project, you do some, you know, retrofitting, and then you start playing with the technology, and you see that with the next projects, with the greenfield, you can use the same technologies. You can, you know, maybe use a different protocol, an evolution of the protocol you were using for the first project, but, you know, the technology is the same, the security that you've set in place is the same. So it's really easy to start from there and moving right forward with projects.
It's also a way to future-proof your investments, right? We talked about the challenges of starting with an IT project. You know, you start small, you start with the MVP, but you want to make sure that you start on solid foundation in terms of technology, that as you evolve, as you embed the connectivity into your products, as you move to a software-defined, right? So where you actually just move the gateway from a piece of hardware to a piece of software that is embedded into your product itself, the technology foundation blocks that you have used are the same, right? That will give you future proof. It will reduce your investment, reduce your risk, and allow you to evolve your services that are associated with the product themselves.
Exactly. Thank you both so much. That's a really great answer. And, you know, as you mentioned, with a good plug for System Ready, but as you mentioned, it is super important for both PSA certified and System Ready are key critical for these for these deployment scenarios. Excuse me. I've got one final question about the kind of scaling up, right? Scaling these industrial IoT projects. Could you talk a bit more about some of the challenges of how you scale these industrial IoT projects to hundreds, if not thousands, of deployed devices?
Or hundreds of thousands, literally, right? We have deployments that are going up to the 300,000 connected devices at this point, right? And more. With ramp-up scale that gets exponentials, right? All these projects, they seems to start, I mean, the patterns that we have noticed over the years is that they start pretty low and they are ramping up really slow initially. And you think, well, we can manage this, right? And then all of a sudden, it catches on fire and it goes exponential, right? And every year you actually start doubling the deployment that you had the year before. And if you don't have a solid foundation that you rely upon initially, you actually break apart. You break apart from a manufacturing standpoint, from the ability to prepare this device, to commission them, to deploy them. And it's not just the scalability on the number of connectivity. Think that each of these devices has a certificate. Each of these certificates have an expiration date. They may have a certificate authority. You may need to enroll them. Each of the devices has a firmware. You start having 400,000 devices, maybe not all of them are on the same version. So how do you manage them, right, as you go up, right? So the challenges are massive. The suggestion here is that start thinking about scaling early on, right? So design this project early on. It's easier than said, but the best way to do it, again, is follow the right blueprints, right? So move to a passwordless design, make sure that your certificate manages into PKI, adopt open standards, because this will allow you to do better integrations going forward, reduce locking on proprietary products, and lay them down, right? We at Eurotech are offering some of these as services, helping our customer to scale up, right? So we offer customization services. We can help our customer in creating a golden image for these gateways. So they have a special order code that they get ready to use gateways that go directly from our factory down to the installation site of our customers. And with the plug and play technology, they get the right operational credentials and get connected to the cloud, right? So engage with an ecosystem partner. IoT is not a single supplier solution. You have to build your own ecosystems and make sure you're designing scale from the beginning.
Amazing. Great answer. Thank you both so much. And I think we're just going to reach time in a second. But before we do, Marco, Luca, is there anything you want to add as a final point, final call to action, final thing you want to say to our audience?
It was definitely great to be here. So Tobias, thank you again for the opportunity. We hope there will be others in the future. We're very excited about what we have done with ARM. We're actually proud of the results that we have achieved. We certainly welcome, to discuss a real world project with some of our people that are attending this TED Talk.
Yep, and you can find all the documentation on what we have seen in the demo in esf.eurotech.com and ec.eurotech.com. Just to
absolutely
to add something.
Amazing. Thank you. Well, Marco, I'm looking forward to meeting you at Embedded World, and Luca,
excellent.
I can try
Same
and
here.
find a way to get up to Northeast Italy where you're both based. So I'll find a way.
Excellent. We'll wait for you here. You're always welcome.
Yes,
exactly. So, but both, thank you both so much for a great talk. Audience, thank you so much for joining. If you've got any questions, please reach out to us. The slides and recording will be available immediately after today's talk on our website. So without further ado, that's enough. That's everything from me. Thank you so much for joining, and thank you, Marco and Luca, for a great presentation. And we'll see you next week for Kixo's Tech Talk, and then we'll hopefully see you at Embedded World in 2 weeks' time. Thanks so much, everyone.
Thank you, Tobias.
Take care.